Delhi, India. And again, I'm welcoming to the technical session 3C at NICE TEAS 2025, Networking International Conference on Emerging Trends in Expert Applications and Security, a truly global academic initiative hosted by WSG University, Poland, and managed by KK Consultancy. The conference proudly reflects the spirit of the global academic integration strengthened by the presence of esteemed partners JECRC University Jaipur, IES University Bhopal, and the community support of Shri Karni Universe College Jaipur. Our publication partner Springer Nature brings scholarly rigor to the initiative through its Scopus-indexed and highly reputed LNNS series. This year, we received an overwhelming response from across the globe with over 500 paper submissions after eliminating AI-generated and plagiarized content. The following a rigorous and following a rigorous peer review process led by an expert panel of academicians and industry professionals on the top, only the top 90 papers were selected for presentation. Following the successful presentation and based on recommendations from our esteemed session chairs, these papers will now be published by Springer Nature. With that, I'm pleased to introduce our session chair for the segment, the session chair one, that is Dr. Francesca Di Virgilio, Professor, University of Malais, Italy. Ma'am, would you like to say some of the opening words?
Thank you for this presentation. I'm very excited to start because let's do listening the paper with the first researcher or professor that in our list to list for is research. When finish, Aparna, please look very well the time for each researcher and. I'm ready to start. Let's see, and good luck for all research professors that are involved in this session.
Thank you so much, ma'am, for your valuable words. Now, I would like to introduce the second session chair, that is Kannad Racer, Director, MIT Cognitive Computing and Brain Informatics Center, MIT University, Jaipur. So, would you like to throw some light on us? Sir, you are not audible.
So, very good afternoon from my side. I think I joined a little late, so I could not hear the previous part because I joined on time, but I think already it was started. So I missed the initial parts. I extend my heartiest welcome to all the participants. We are looking for some good paper presentation here, and after the sessions, maybe we'll discuss about these papers. Thank you very much.
Thank you so much, sir. And with that, now before presenting the papers and proceeding further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has only 4 to 5 minutes. Please stay within the time limit. Secondly, briefly cover your research context, objectives, methodology, key findings, and conclusion. Third, a short question answer may follow your talk of 1 minute. Keep responses brief and focused. Fourth, keep your mic muted when not speaking. And fifth, stay for the full session to support your fellow presenters. And now, with the kind permission of our session chairs, we shall now proceed with the paper presentation. Ma'am, should we proceed? And sir?
Sorry, I think there was some request from paper number 549. Probably he would be liking to present it before the others, because of there's some urgency. So please just check that one.
Yes. So I would like to invite our first presenter for the day, presenting the paper title Privacy in the Age of AI, Regulatory Challenges and Risk Governance in Expert Systems by Shobhitab Srivastava under the code 549. You
Thank
may,
you, Aparna. Thank you so much for giving me this stage. I'll request Dr. Kunal to kindly share these slides. And while these slides are being shared, we know that the title of this paper is the Privacy in the Age of AI, a Regulatory Challenge and Risk Governance in the Expert System. It is often said that even if there's a technology to go to hell, even if there's a technology which places or which advances in going to hell, then law follows. So, we in this paper have focused upon the legal aspects of the artificial intelligence, especially focusing upon the privacy, the risk which AI brings itself pertaining to the laws in which the individual's private rights are infringed. So, to introduce the methodology, we have followed a doctrinal method in which we have picked up laws, particularly from India and European Union, the GDPR law of the European Union, and the DPDP Act of India, which is yet not enforced, but it has been passed and will soon be enforced, which again focuses upon the privacy of an individual when they are being subjected to the algorithms of the artificial intelligence. Uh, our object of this study has been that the expert systems in the artificial intelligence, as the slides also says, the expert systems in the artificial intelligence are wide and they cover almost all the areas which were completely and solely being governed by human beings alone, be it medical field, be it business decision making, be it even judiciary, the arbitrations, mediation, conciliations are being done by artificial intelligence. At times, artificial intelligence may only analyze the data, but on in the other aspects, it also comes to the extent of decision making. So, in case where there are best practices, where they may lead to financial gains in a business production, and on the other hand, there may be instances where the AI, without the personal consent of the individual, personal consent of the person, engages with his personal data. Now we have to balance these two aspects of use of artificial intelligence, and this has been our objective to study and to analyze the balancing of the expert system and the privacy rights which come along with it. Now, we all know that expert systems play a vital role in uh, uh, in providing valuable healthcare data of, like for instances, where predictions can be made even more effective than the predictions by any human being. So AI data can actually mm, study the the previous predictions because it's a law what we are venturing into. So what may happen is, say, in case of an individual person, when all of his data are being fed to the artificial intelligence, some expert system, so his healthcare is being compromised, his genetic history is being compromised, his racial identification is being compromised, and his behavior, things as minor as his sleep patterns are being compromised with the certain data fiduciary. Now, this data fiduciary is an intermediary who will save all the data, and all the data will be protected by him. In the light of the same, next slide, please. In the light of the same, we know that they are very efficient in the society, but we have to strike a balance with respect to the individual's right, where all of these data are being shared. So the very first thing that comes in is at least with respect to the person's consent, whether all of this data is being shared by the consent of the person or not. It is an important aspect to take the data or to take his information into the artificial big data pool on which artificial intelligence are being fed. One of the major concern in this regard, which has come from primarily from the US,
who have employed the concept of predictive policing is also relevant, because predictive policing also does the same thing. It works as an expert system. It works on the data which is being fed to this artificial intelligence expert system. But when the data itself is biased, then what will be the outcome? The outcome will be biased as well. Next, please. Now we have been talking about the profiting and the the inferred information in the AI. So the profits are at one place, but the ethical questions remain intact. In this regard, I would like to talk about DPIA. DPIA is Data Protection Impact Assessment. But there's a very popular
Sorry to
concept.
interrupt, sir, but we are running short on time. Could you please wrap up fast?
Yes, I'll just wrap up. I'll just talk about DPIA, which is very important. After that, I'll just conclude it. So, in fact, I also had to compare the GDPR and DPDP Act. However, I'll focus on the DPIA because that is the major point of distinction between the two. Now, DPIA is something which is Digital Protection Impact Assessment. So, in that case, it has to be analyzed. We can understand it drawing a corollary with the environment. So, say you are holding a simple feast, you are holding a simple party, and you are holding it in an open area. So, either one, you can hold it in the open area in a park, or second, you can actually destroy 10 trees and then hold a party and hold a gathering. So, the second ones will be more impact, will have more impact on the environment. So, environmental impact assessment, it will be not allowed. Similarly, if a certain kind of data are being used by the experts, in which the sensitive data of a person, including his genetic history, his racial distinctions, are being met. So in that case, a specific consent needs to be taken, which is there in case of GDPR, but not in case of DPDP. Fine. Second important thing which I wanted to bring in, and I'll just conclude after this, is with respect to the concluding part. Important absence of the legislations. In fact, IT Act is there, DPDP Act is there. I'm talking in the respect of India. Information Technology Act is there, DPDP Act is there, but none of them actually focus upon the right to privacy or confidentiality or privacy. Justice Puttuswamy case has been a very important case in which the Supreme Court has told that the right to privacy must be maintained of a person, but artificial intelligence on the regular basis can infringe the rights of any individual without his consent. Article 8 is of the European Convention on the Human Rights, is an international instrument on which municipal laws can be made. And all the countries should make use of this law. I would just request Dr. Kunal to get the slide of distinction between DPDP and GDPR. This is on the screen. My distinguished session chairs can read this. And in this, the what I have been talking about, the most important aspect is DPIA, Digital Protection Impact Assessment. That is something which each and every expert systems should look into. There should be no more black box. That is the opaque nature of the decision making by the AI. The more black box, the more opaque nature of the AI, the more trust it will gain. Oh, okay. So we have been getting forms and other things in the chat box. Aparna, do I have more time?
Sorry, sir, your time has been up. But if you
Okay.
want, you can conclude fast.
Okay. So my conclusion, I would like to talk about. I have 3 points to conclude on. First, that we know that there is lack of any law. In fact, GDPR is also not being able to meet the fast growing expert system fed by AI. So we need such laws. However, the consent part is very effective in GDPR, but that is not there in DPTP. So first thing is consent. Consent is important. Second, data processing. That is the DPIA. DPIA must be effectively implemented. It should not only be in the papers. So why I give this environment example? I gave this environmental example because that is something which has been effectively implemented by countries, all the countries, because this has come from a international instrument by in the Rio de Janeiro conference. So this should also be implied in the DPIA. The third point which I am focusing upon is with respect to the confidentiality of the artificial intelligence, the data on which it feeds, and it has to be handled by data fiduciaries. Data fiduciaries should be penalized, or there should be a provision to penalize these data fiduciaries if they leak or reveal the data. A quick few suggestions. First is harmonic AI governance is required. It needs a framework. Data of the ideals, that is, it should be transparent. It should be responsible to focus upon justice aspects of it. Then it has to mandatory data protection assessment should be there, DPIs, which I have been emphasizing upon. Informed consent should be there, and they should and the developers of the AI should minimize the data collection to solve the algorithms. Public awareness efforts should be increased, and constant updating of rules to match the evolving technologies. It should not be that a law has been passed today and it remains the same forever. Thank you again. I'm open for any questions if the session chairs have any.
Uh, may I submit one question? Am I audible? Am I audible?
Yes, you're audible now, sir.
Okay, okay. So just one quick question, so how feasible is it to balance commercial innovation with meaningful public engagement and
Mhm.
transparency, especially in countries where digital literacy and regulatory capacity are unevenly distributed?
Sir, I'm really sorry I could not get your exact point. How feasible it is it to balance the
Commercial innovation with meaningful public engagement and transparency, especially in countries where digital literacy and regulatory capacity are unevenly distributed.
okay, okay. So now that we this conference we are talking about is with respect to artificial intelligence primarily. So I suppose that what the question is arising from the arena of artificial intelligence. So commercial innovation with the help of artificial intelligence is what you are asking. So, sir, in such cases, I think while awareness is important, at the same time, the knowledgeable base of a country should come together and should devise laws in which the consent and the data fiduciary is important, because there will be, like in the DPDP Act, there's a term which is used as data fiduciary. Data fiduciary is an entity which holds the data. So if now these people who are holding the data are certainly informed people, they certainly are capable to make a machinery or make such data capability that they can hold such data. Penalizing them is the primary thing which can be done to at least make the machine learning or the owners of the expert system liable. So, because we cannot educate the whole population at once, so let us hold somebody in the between, and then slowly we can also, educate the population on the digital aspects of the AI.
Oh,
That is my answer, sir.
Aparna, I have any minutes for demand? I have a
Yes,
minutes.
ma'am.
Yes, I have a minutes for questions to the researcher.
Ma'am, can you ask in the next one? As we
Okay,
are out of time. Sorry to say, ma'am.
okay,
All
okay.
right. Thank you so much, sir, for your
Thank
insightful
you.
and well articulated presentation. Now we are
Thank you.
moving further by calling upon for the second presenter of the day with the paper title Improving the Efficiency of Sentiment Analysis System Based on Integration with Robotic Process Automation and Knowledge Based System under the paper ID 340. I would like to request Van Hushu, sir, to kindly come on the virtual stage and begin with the presentation. Over to you, sir.
Hello, everyone. Today, um, I would like to present our research topic is improve the efficiency of sentiment analysis system based on integrated robotics, process automations, and knowledge-based system. Our main objective is to improve the efficiencies and scalabilities of sentiment analysis system by integrated robotics process automation (RPA) and knowledge-based system (KPS), with a focus on processing Vietnamese language learner feedback from social network in real time. The key research questions guiding these studies are how can RPA and KBS be effectively integrated into data segmentations, and how can the system efficiently manage a larger keywords repository and classify data into department without continuous database access. And now to understand how we answer the questions, cities, ter- cities theoretical foundation. The first sentiments analysis is essential for classifying user feedback and as positive or negative. Um, and next, APIs automate repetitive tasks such as collecting data from social and sending alerts emails. It reduces manual efforts and integrates easily legacy system. And finally, knowledge-based system KPS is in-hand classifies by storing expert knowledge and enables real-time updates through API integrations, allow dynamic keywords to department mapping without database query. Now, thus we understand the theoretical variations, the importance of emotion analysis. Let's dive into methodologies behind our system, which is divided into major parts, the datasets and proposed models. In these studies, we automatically collect over 10,000 student posts and comments from social media um, platform managed by Vietnamese universities. The data were then processed by removing noise, and we selected a sample of 100 manuals label and tried to test the classification models performance. With And next, we use UiPath as the main RPA tools in this study. It automatically collects student feedback from social network and send email alerts to department when negative sentiment is detected. This automation significantly reduce manual workloads, ensure timely response, and have minimized the risk of human errors in the communication process. The keywords base in our system consists a set of keywords that map to specific department. The keywords are maintained and updated in real-time tools API integration and stored in memory dictionaries to enable fast access. We For semantic analysis, we use for burst a pre-training Vietnamese language model to extract vectors representation of learner feedback. The vectors are then compared to department vector using cosine similar to determine the best match at and next we design a, 13-step workflows that combine RPA bot for automating data collection and email notification, human reviews and updates the list of keyword for each department, a list based for mapping feedbacks to department. This end-to-end process allows learner feedback to automatically connect, analyze, and send to the right department in real time, ensuring timely and accurate response. We developed two software robots using UiPath. The first robot automatically connects posts and comments from learners on social network. The identifies on outputs from these robots are integrated via API to support seamless processing in the next stage of the system. We connect over 1,000 student posts and comments and selected 100 sample for training and evaluations. To build a complete system, we implement two components. First is the knowledge-based, and the second is data classification process. The system uses
Sorry
the
to interrupt, sir. So we are running short on time. Could you please wrap up fast?
Yeah, okay. And now I want to talk about key findings and discussions. We successfully integrated API and knowledge-based system to automate data collection and classifications. At 0.6 similarities thresholds, the model's risk 86% accuracies, and an advanced score is 0.7 T3. The API-based knowledge-based system enable faster and more scalable performance. The system will test on over 1,000 real student posts and can adapt to other fields like customer service or public service. And some key challenges in implementation in the system. Data must come from official public source or change platform policies may affect stabilities. API tools like UiPath are effective but can cause needs. Our approach balance perform and efficiency using Phobos and with communities. Also, since the keyword needs, it can be updated. Future work should include shared learnings and multi-link support. In conclusions, our system successfully integrated API and KPS to improve sentiment analysis. It automates entire process from data collection and classification. The use of API-based allows for real-time updates and scalability. This solution is well suited for higher education, but also has potential potential for broader applications. With future research, we plan to enhance the system by integrated self-learning model like LSTM and CNN to automatically update keywords. We also aim to explain the capability to support multi processing applied in other fields. And thank you for your attention. I'm now open to any question or discussion about our studies. I think I will try to improve in the future.
Thank you for this interesting paper. Is very actually this problem. The first question regards the period. Which is the period that you collect data? The first question, because it's important, is you collect data for a particular month or during 1 year. The second aspect regard the sample, this student that have access to the social media of the institution, which is the types or typologize of the student. This is the to them and regard your paper, curiosity about your collect data. The second aspect is very interesting in the future to have the opportunity to collect data for another country in higher education institution. So to have the possibility to a longitudinal analysis between two samples of students from, I think, your country and your country where the culture also to use social media is different from the same sample of students. Thanks for this moment to share.
Thank you.
Please, I repeat my question. Which is the period when you collect data?
Okay. You are right. The times previous data collections for understanding the context of the sentiment analysis is very important, and in our studies, the data were collected over month previous from now. Specialists from groups on Vietnamese universities where students continuous share opinions. However, we acknowledge that stating exact durations, exams 3 months or 6 months or 1 year is important for the future visions of the papers to enhance transparencies. I think so. And about Thai profiles of students. Thank you for the raising this point. In the current studies, we did not segment the data by student type, such as by measures of academic years or demographic characters. On feedbacks was treated who put it, and on learners is students whose they are studying from 1 years to 4 years. I think so.
Okay, thank you. Now it's clear. Thanks for your response. Good luck for the future of this research.
Thank you so much.
Thank you so much, sir, for your insightful and well articulated presentation. Now, I would like to call upon the next presenter of the day, that is, with the paper title Machine Learning Based Optimization of Solar Street Lighting for Enhanced Energy Efficiency, under the paper ID 489. Ma'am Hema Prabha, I kindly request you to start with your presentation.
Yeah. Thank you, Aparna. I hope all of you are able to see the presentation. Good afternoon, everyone. My research or our research is machine learning based optimization of solar street lighting for enhanced energy efficiency. Myself, Hema Prabha, Geeta and Shravan Kumar Veluranandarangan are the co-authors. To give a brief introduction about our paper, it is about street lighting, which represents a critical infrastructure component affecting urban security, aesthetic appeal and energy budgets, and carbon footprint. So approximately 315 million streetlights all around the world and 27.5 million of streetlights in India exactly. And the primary energy source is coal and gas. So our solution approach is to develop an autonomous, self-learning, intelligent lighting ecosystem that minimizes power consumption through predictive machine learning models while maintaining public safety standards. So the protocol that we used was using the solar energy panels, integrating with IoT sensors and ML-based decision making and an adaptive control. We researched around 20 papers, and the recent one, which was published in 2025, observed that despite advancements in machine learning and IoT integration, streetlight infrastructure capable of real-time adaptation to urban conditions remains understudied. So there is a lack of infrastructure capable of real-time adaptation to the urban conditions for the streetlights. Our research objective, in turn, aims to develop an innovative, autonomous, human-independent, adaptive control system for solar streetlights. We have tried to implement the lux value, which is read from the light sensors, which can help us in differentiating the lighting condition, and based on that, the streetlights can dim or brighten the lights. Our paper spanned over two phases. The first phase was implementing the remote switching of the street lights. We had a setup where we had solar panels and then the LED lights. We replaced the halogen lights with LED lights for energy conservation. We also had an Arduino and ESP8266, which is a Wi-Fi microchip for enabling the IoT technology. We had a server, ThinkSpeak server, which had readings from the various sensors. We had voltage sensor, light sensor, air proximity sensors, and IR sensors. So the readings from Arduino was fetched by the ESP8266 and then fed to the server. Eventually, all the readings were recorded in the laptop and the cloud server. At the end of results of phase 1, we found that the total energy consumed for the LED light, for the operation of Arduino and ESP8266 and the LED display, the total energy consumed was 414.182 watts per hour. And we analyzed that we have to conserve some more energy if we want to have multiple streetlights and adaptability. So the key achievements at the end of phase 1 was successful integration of all hardware components, reliable IoT connectivity and data transmission, effective motion-based illumination control, and stable solar charging and battery management. Our performance improvements, real-time monitoring and fault detection, about 35% reduction in energy consumption because of using the LED lights and the solar lamps. Identified limitations, it did not have the predictive capabilities for proactive adjustments and insufficient learning from historical data pattern. And we had to occasionally use manual threshold requirements. This led to the motivation for phase 2. The LED lamps were selected, and if I want to increase the efficiency of the LED lamps, then the LED lamps illumination can be controlled. That is, it can be brightened or dimmed based on the readings from the light sensor, which can give us the lux readings. And we employed a machine learning model which can help us in optimizing the output from LED lights based on the input from sensors. Our phase 2 was a comprehensive data collection. It started with data collection and preparation, the data site sample, and we had a synthetic data set generated. of sample size 1000, which had features like the outputs from voltage sensor, current sensor, IR sensor, light sensor, and certain environmental conditions were considered, whether the environment condition is clear, rainy, or cloudy. The timestamp we collected was only from 6 p.m. to 6:30 a.m. The main motivation for our research was the fact that sunsets are longer in the months of June, July, and shorter in the months of December, which contributes to the illumination of the LED lamps. Say in case in June and July, we don't want a brighter LED light or a street light, it could be dimmed so that energy can be conserved. The ML model, we had used random forest algorithm. Why? Because of its robustness to overfitting, ability to handle mixed data types.
Apologies, ma'am. Due to time limit, can you please wrap up fast?
Yeah. Imbalanced data is typical in lightning control. So the algorithm configuration, estimators were 100 decision trees. Features, we had considered total features. Random state and maximum depth across all trees were 11. The decision logic, we had two elimination levels. One was medium and the second one was high. The number of input features were 8 and ensemble voting was considered. The data was split into 80-20 ratio. Hyperparameter tuning was done with using grid search CV, and model validation using the cross validation method. Some of the performance metrics were accuracy, F1 score, precision, and recall. At the end of result of the phase 2, we had an accuracy 86.8%. From high intensity to medium intensity, when we had the testing data, it was reduced to 50.66, which led to 20% of energy savings. This graph typically indicates when the power consumption has been transferred from the high to low. That is, 1 is the low intensity and 2 is the higher intensity. When the intensity is shifted from high to low, there is an energy conservation of around 2000 units, which has led to energy conservation of 20%. So our metrics: accuracy 86.8, precision 85.1, and recall is 94%. The most important feature for our data was found to be the light or the lux values, environmental conditions, and the power consumptions. 45% reduction in overall energy consumption, and predictive battery management extending life by 30%. So our research contributions: a novel adaptive system, a first comprehensive ML-based solar street light control system, predictive intelligence by using random forest algorithm, and 45% reduction in power consumption while maintaining the safety standards. So key achievements: autonomous human independent operation, self-learning capability, and significant energy savings. It definitely has a societal impact. We can reduce the carbon footprints, and we can enhance the public safety through intelligent lighting. And it definitely gives rise to the benefits to the government. It can be a foundation for smart city infrastructure development. There is a lot of scope for our research in future. It could be an advanced AI integration, energy storage innovation, or smart city integration. This research represents predictive lighting control, establishing a foundation for next generation smart city infrastructure, focusing on energy efficiency, public safety, and environmental sustainability through intelligent automation. Some of our references, and thank you. Questions?
Thank you so much, ma'am, for your insightful presentation. And we are now open to questions, if any.
I have one query. Do you feel that the reliability and all these aspects would be better dealt by quantum computation?
Yes, definitely, sir. We are in the quantum computing trend now. there is a lot of scope of research in the field of quantum computing can be implemented, but our research was restricted to machine learning model. We did not explore the quantum computing world as of yet.
Yes, 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 yes. Any other question, Professor Gadulio, if anybody or anybody from the audience? I think I think no question. So
All
Aparna,
right, seeing no questions,
thank you
we'll
for this
move
conversation.
further.
Thank you, sir.
Yeah. Thank you, ma'am. Thank you, sir. All right, moving further to the next presentation of the day with the paper title AI Driven Credit Risk Modeling in FinTech Under Global Tariff Induced Economic Volatility. With the paper code 530, I would like to invite Miss Jaya Eripilla for the presentation. Thank you, ma'am. Over to you.
Are you able to see my screen?
Yes, ma'am. Yes, ma'am.
Okay, thank you so much. Hello everyone. Today we're going to present the paper about AI-driven credit risk modeling in the fintech industry under global tariff-induced economic volatility. This paper is a collective effort of our team members, myself, my name is Jaya, and my co-author and speaker who will be joining today is Ram, Durga, Uttama, and Vamshi. So what made us choose this paper? First, I would like to define what is tariff. Tariff is a tax that is imposed by the government on the goods or services for a country which is importing and some of the exports also. To give an example, we are getting like we live in US, and any example of getting some goods from India, there is a tariff being imposed. And in the recent geopolitical shifts, there is a huge tariff differences that is being imposed, which is creating a byproduct or creating a consequential effect of how fintech industries, especially fintech lenders, are being impacted. And that is what our paper is talking about, and how the impact of this fintech lenders can be mitigated using our AI driven credit risk modeling approach, which we'll be discussing. So in this, we'll be talking about the challenge, what are the economic impacts because of this, the limitations with the conventional risk model, and the framework, the new framework that we have come up with, the implementation, the results. To begin with, what the context, the global tariffs are increasing from 10% to over 100%, disrupting supply chain, raising cost and increasing inflation. And there is a huge unprecedented environment because of the geopolitical shifts, international from the international elections, and every country wanted to protect their own by using these protectionist policies. The impact of fintech lending is impacting on the delinquency risk. Delinquency is somebody who are not able to pay back their loans, and this delinquency risk is hugely impacting and creating a lot of losses. So that is why we have a need of AI to how to mitigate this issue. The economic impacts on fintech lending are: one, the cost inflation. Uh, Initially, if there's a 46% tariff, there is an increase in additional prices by 25 to 30%, and the rising in delinquency where people are not able to pay back the money, and even the loan demand is also falling, which is impacting the fintech lenders. And also, because of this, there is a huge regulatory pressure on how the policies or the algorithms have to change to mitigate identifying the high risk applications and not to give them the loans. So the traditional model is heavily depending on only credit scores and income, which is not a dynamic real-time analysis. Because of which we will be presenting what is the model or framework that we are coming up, which can actually capture the real-time behavior. With that, I would like to give the Ram to speak over.
Hi, good morning, everyone. My name is Ram Ram, and I work in fintech risk control assessment platforms. So, regarding our framework, like AI-driven credit risk modeling framework, it is an integrated approach of XG Boost and LSTM, long-term, short-term memory, dynamic predictions, and it is a kind of open source and reproducible thing. With Google Collab, we have done the research, and we used scikit-learn and TensorFlow, XGBoost, and etc. These are the libraries which I used. So basically, consumer data will come, and that will be fed into XGBoost scoring and LSTM for predictions, and social media alternative data processing, and we have enhanced the features. And these are the three legs of data which is coming, and we are processing that. And next thing is, it will go to the risk assessment platform, and based on this, loan decision will be made by the fintech vendors like FM or Sophie. So basically, it is a kind of regulatory compliance also, because if more and more fintech institutions are failing, then it will lead into disaster. For so regulators has to impose some of the rules and regulations. So this is the key things, key components of the framework. This is a XGBoost. XGBoost is for static risk scoring, and LSTM is for dynamic repayment forecasting. That is called long short-term memory. It is basically a deep learning technique, and alternative data integration also we have done with transaction history and digital behavior.
Apologies, sir, could you please wrap it up fast as we have less time?
Yeah, so we have, this is the implementation methodology. We have simulated experiment with 1,000 transactions, and model training was done. And as I mentioned, open source tools like scikit-learn, TensorFlow, XGBoost were used. So it is easily reproducible. And results and accuracy and impact. Coming to results and accuracy impact, it is a superior, LSTM is a deep learning library. It has ROC AUC of 0.82. It is outperforming the XGBoost 0.73. And implementation challenges are like LSTM is a resource intensive. So these small vendors cannot hold the platform, because it is little bit cost affair. So I think what we are concluding is XGBoost. Can you go back to the graph, please? Yeah, so XGBoost, if you see the model performance, ROC and AUC, the model performance of XGBoost is 0.73 and LSTM is 0.82. The gap between these two are the performance indicator which we found. This is with this approach, LSTM approach, I could able to save a lot of money. For example, $2,500 daily for 1 million portfolio. This is the simulation which I have done, and it was working perfectly fine. And LSTM outperformed XGBoost in terms of predictions. This is what we found. So basically, it is a kind of money-saving tool, identifying risk because of tariffs and global paradigm, global election, and political influences. And we took the data and we saved the fintech lenders to avoid losses. And again, it is indirectly impacting or directly impacting regulatory compliance also, because regulators has to put a vigilance on the fintech vendors, how they're and to enforce any rules or something like that. So this is very useful for fintech lending platforms. Thanks. Any questions?
Yes, I have any questions. It's very interesting, this paper, because in this period to analyze the risk model, in particular period where in the world there are many wars that impact on this data. So in your conclusion, you analyze the role of artificial intelligence, but with your research co-authors in this paper, also the machine learning is an opportunity to analyze this data integration. Why you decide to use artificial intelligence? Because from data in these few slides, I understand there's few to explain better the paper, your research. But I think also machine learning have the opportunity to achieve the same results in your research or not? Why you decide in artificial intelligence also for the future? And the second aspect, the indicator that impact on fintech, also the war in this particular period is very important to analyze because have an important role to analyze the fintech and so on. This aspect that impact of economics in each country is very different. For example, Europe from America. Why you? My question regard in particular why you decide to artificial intelligence and not machine learning to analyze also in the future this data. Thanks for this interesting paper.
Yeah, thank you. So basically, we have machine learning, we have deep learning. Everything will come into a universe. So deep learning has interesting library called STM, and which uses TensorFlow as well. It is more accurate, and the prediction, as you saw the ROC and AAC code, the accuracy is more, at least I can say 9 to 10%. So it is very crucial. Maybe 9 to 10% is very less, but the thing is, it is very crucial for fintech institutions, and I try to adopt latest AI techniques for this. That is the main reason which I selected. Normal traditional way is XGBoost. That is the machine learning technique. Thank you.
I have one question, a query. So, what machine learning strategies are most effective in capturing non-linear financial risk associated with tariff-induced economic disruptions in credit scoring systems? Non-linear financial risk. Which machine learning frameworks are the more useful?
I would say non-linear thing is random forest. I would say some other machine learning algorithms are there for non-linear identifications. But yeah, so that is the answer for that.
All right. Thank you so much, sir and ma'am, for this wonderful presentation. Now we are moving further to the next presentation of the day with the paper title "Detection of Node Replication Attacks Using Clustering and Ensemblance Methods in WSN" under the paper ID 22. I would like to call upon Miss Anusha Sobarnika V. Are you there, ma'am? I believe ma'am is not here. So moving further to the next paper title, that is Sentiment Analysis and Deep Learning. Under the paper ID 547, I would like to call Apurva Vashisht ma'am.
Okay.
Ma'am, please make sure to try to complete the
Yeah.
presentation within 5 minutes. Thank you, ma'am.
Yeah. Sure. Thank you for giving me the opportunity. And good afternoon, sir. Good afternoon, ma'am. Lovely to meet you. And my paper, I'm very new to this research field, so I have not done like a very great work, but I've tried my best. So yeah, I'll present now. Just a second. I'm sharing my screen. Tell me if it is visible or not. So yeah, just a second. So my paper title is Sentiment Analysis Using Deep Learning, and my co-authors are Pushpendra Sekarwal and Palak Khandelwal. And I'm from Department of Computer Applications, JECRC University, India. So introduction to sentiment analysis using deep learning, key points. Natural language processing plays a vital role in understanding human emotions through text. Social media, especially Twitter, generates large volumes of user opinions that can be analyzed for first, public sentiment; second, market trends; third, product feedback; fourth, political opinions. The paper proposes a supervised deep learning approach to classify tweets as positive or negative, further break down emotions, example, joy, anger, anxiety. And for this, I had organized, I have used the algorithm called LSTM, which is long short-term memory models for number one, handling sequence data, and second, improving accuracy in emotion classification. So I have achieved the accuracy of 89.13% for emotion subclass predictions and 88.47% for binary sentiment, positive/negative. My keywords, Twitter sentiment analysis, like whatever I have used in this. Second, motivation and research objectives. Massive growth in user-generated content on platforms like Twitter. Text-based emotions are harder to interpret than facial or verbal cues. Businesses, governments, and researchers need automated tools to understand public opinion. Traditional ML models struggle with context, sarcasm, and complex language. Deep learning models are there, such as LSTM, offer better accuracy with less manual feature extraction. Then I have built, my objectives were to build an efficient sentiment classification system for tweets to identify and classify emotions into positive and negative. Then again, evaluate the performance of LSTM, then pre-processing pipeline and public opinion analysis. Next is literature review and related work, key findings from prior studies. So this paper was published in 2009, which introduced distant supervision using emoticons for Twitter sentiment classification. Then there were different findings, and based on that, I've done my research. System architecture for sentiment classification. First of all, I've collected the data, tweets scraped from Twitter using APIs. Datasets include labeled positive, negative, or emotion-specific tweets. Removal of URLs, hashtags, user mentions such as @ emojis, and retweet makers. Lowercasing, punctuation removal, and word normalization. Then feature extraction, classifier. I have used the LSTM-based model used for binary sentiment classification and output layer. Coming to the next point, why pre-processing is important. Tweets contain noisy and informal language. Pre-processing ensures clean, consistent, and machine-readable input. It improves the accuracy and performance of deep learning models. So basically, what are the steps? First is lowercasing, then removing URLs and mentions, then clean hashtags, then replace emojis or emoticons, remove retweet markers, remove punctuation, normalize elongated words, and tokenization. So the outcome is clean and standardized tweet data ready for deep learning classification. So why have I chosen LSTM architecture? LSTM, long short-term memory networks, are designed to handle sequential data. They can retain context over long text sequences, solving the vanishing gradient issue in standard RNN, ideal for capturing emotion flow and sentiment dependencies in tweets. So the model overview, we have input layer, which is pre-processed and tokenized tweets. Then we have embedding layer, converts words into dense vector representations. Then LSTM layer, dropout layer, dense layer. Then the accuracy. I have used 3 data sets. Dataset 1, tweets labeled as positive or negative. Dataset 2, positive tweets categorized by emotions. Dataset 3, negative tweets get categorized by emotions. Then tweet classification workflow. Coming to the next point, evaluation metrics used. Accuracy, correct predictions out of total predictions. Then precision, correct positive predictions / total positive predictions. Recall, correct positive predictions divide by total actual positives. F1 score, harmonic mean of precision and recall. Observations, LSTM
Sorry to
model.
interrupt, ma'am. Can you please wrap it fast?
Yes. So coming to the conclusion, sentiment analysis using deep learning LSTM effectively classifies tweets into both positive, negative, and emotion categories. The model achieved high accuracy even with noisy and informal Twitter data. Pre-processing plays a crucial role in boosting classification performance. LSTM networks are well suited for text sequences and context-aware emotion detection. So the future work will be enhanced performance using hybrid models, LSTM, CNN, convolutional neural networks plus attention. Extend the system to support multilingual and code mixed tweets. Incorporate real-time sentiment tracking for live events, elections, or market trends. Investigate hierarchical models for deeper understanding of complex emotional patterns. Fifth, integrate advanced attention mechanisms to better capture long-range dependencies in text. Thank you so much. Any questions?
Am I audible? I have a question. Am I
Yes,
audible?
sir. Yes. Sure. Yes, sir.
Okay. So, what are the key challenges in training deep learning models for sentiment analysis, especially when we are dealing with multilingual or domain-specific data sets?
Sir, in
When you are dealing,
yes, sir. Yes, sir. I got your question. So, sir, in multilingual data set, we can classify the different languages word into like what are the good words and then what are the bad words, what come under positive words and what come under negative words. So that is how. And second of all, sir, we have NLP, if you know, natural language processing, the library that we use. So under that comes different languages. So that is how we can like classify multilingual data, sir. And for now, I've used only in English, sir, because I did for Twitter data and basically categorizing the data into positives and negatives, categorizing what is good and what is bad, what is positive and what is negative.
okay.
A fast question because you have few minutes about this. Sentiment analysis about the emotion is my research topics. I published about the emotion, but I think there is a limit because positive and negative is only two cluster of emotion. But you have the opportunity to analyze more emotion. In particular, you use X Twitter for analyze the message or another social media, because about your research is very interesting also for the future. Choose, for example, Instagram, that you have more data, and also to analyze this sentiment analysis, because sentiment analysis regarding emotion is not only positive and negative. There are many many insights. I think that you are studying about this.
Yes,
Okay.
yes, ma'am. I will try a different social media platform and I'll work for the future enhancements. Thank you so much, ma'am. Thank you so much, sir.
Thank you so much, ma'am and sir, for the wonderful presentation. And moving further to the next paper title as Enhancing Emotion Prediction in Music Through Assortic and Lyric Features, an Efficient Machine Learning Approach, under the paper ID 535. I would like Mr. Rahul Kumar Kikar to please come upon and please conclude the presentation first. Sir, are you there? I believe sir is not here. Moving to the next presentation with the paper title Remote Sensing Reveals Land Cover Dynamics at Sidkal Industrial Estate, Haridwar, a sacred city in the Himalayan foothills, India. With the paper ID 579, I would like to call Miss Pooja Joshi to kindly come upon and present and try to conclude within 5 minutes.
Am I audible?
Yes, ma'am, you are audible.
Okay, thank you so much. Well, good afternoon and good evening to esteemed professor. Today, I am here to give my presentation on uh, remote sensing reveals land cover dynamics at Sitikul Industry Estate, Haridwar, which is a sacred city in the Himalayan foothill, India. So today I present critical insight into the environmental transformation of Haridwar, basically. So it is one of the India's 7 sacred city where annually 12 million pilgrims seek spiritual solace and amidst the Himalaya foothills. But this landscape nowadays facing a salient crisis if we talk about in terms of rapid urbanization, climate vulnerability, and ecosystem fragmentation. So through our paper, we try to analyze and quantify the changes that occur between the time period of 2018 and 2023. So that we can reveal the urgent tensions between the devotions and the sustainability. So this is our study area. This zone basically between the Gangetic Plains and the Himalayan ecosystem. It is spanning about 195 kilometers squares, and as far as concerned that how we acquire our data for the processing. We have, as we know that today now the traditional field monitoring is not that much impactful or not able to capture up to the scale the way today we have Google Earth Engine, which is doing the processing in a petabyte scales. So we have used advanced scale observation. We are leveraged with the ESA Sentinel-2 constellation, which processes the surface reflectance data in Google Earth Engine platform. So to ensure the precision, what we did, we basically analyze March composite, because in India, in this region, this is a dry season, and so that we can minimize the cloud interference and the phenological noises. So using, we have used the 13 cloud filtered scenes. 6 we have took from 2018 and 7 from 2023. And we generated monthly median composite. This approach basically preserved the land surface integrity while suppressing atmosphere artifacts. So these are some pre-processing we had performed before making the classification on our ROI. We have considered the 3 indices to drove our analysis. First is normalized difference vegetation index, which basically tells or measure the vegetation health. And second is the modified normalized difference water indices for observing the state of the water bodies. And the third is NDBI. It is all about the built-up areas. And there is a threshold for each indices. If, for example, if we talk about the NDBI, the value if encounters more than 0.1, so we ensure we could say, okay, this is the place where the built-up is existing. So these are the result that we have derived. We have depicted it through the table. Built up area, as we can see that it is 66.49, and in the year of 2018, which is accelerated, the percentage change is 2.89. 2.89. So definitely our result shows that built up area is enhanced, and so the dense vegetation is declined, and the barren land, there is increase in the percentage of the barren land also. These are the pictorial presentation that we have did the difference, classification difference between the year of 2018 and 2023. The red pixel basically defines the area where the built-up index is increased over the period of time. The adjacent one is reflecting the spatial pattern of water index. But this water index is basically...
Ma'am, can you please wind up fast?
Okay. But these are the not the natural resources. These are the man-built reservoirs. So the NDVI vegetation index has been reduced in the Sidkul area and the BHEL. These are the industrial areas where definitely we can see there is a difference between 2018 and 23. the enhancement of the decrement in the vegetation can be clearly seen with the help of red pixels. There are three interconnected drivers that basically drives the propel these changes. First is pilgrim infrastructure. Because of the Char Dham highway project, it has been fueled 18% increase in hotel footprints. That's why the urbanization is rapidly increasing in these areas. And secondly, this also affect the cropland, which is shrunk by the 9%. And third one is the climate feedback loop. 12% decline in Himalayan snowpack, reduced underwater recharges also. So these are our observations, and we have also find out that there should be a demandable there should be a actionable solution from the end of local NGOs and the governments. For that, they can deploy the micro scale monitoring using 3-meter planet scope data to detect encroachment near the forest areas or dense forest areas to protect the Himalayan foothills, like Shivalik elephant reserves. Secondly, we can establish eco-sensitive zoning so that we can shield critical corridors by using the NDBI, the hotspot that we have projected in our pictorial representation, the NDBI and NDVI hotspot maps. And third, there should be an implementation of compensatory water budgeting, so that new development construction which is happening because of the need of the today's era, so they should construct equivalent water storage capacity also. So because this study is not only the abstract idea, and we are here this study targets the intervention, what kind of intervention derived from the pixel level evidences. So we try to cover these points through our paper presentation. Thank you. Any questions?
Thank you so much, ma'am, for your valuable insights. If there are any questions from the audience or session chairs, please proceed.
Okay, so one question, because when I was discussed about some of these implications of these, particularly the environmental implications, and also hinted somehow. So I just wanted to ask something about what are the basic implications of the socio-economic implications. Basically, maybe you have hinted somehow, but if you can little bit elaborate, because of the satellite-based remote sensing, images you found, and there could be some socio-economic implications. So how that could change, and that could bring some change in circular areas.
So, okay, thank you so much, sir, for the question. But the thing is, for this particular domain, the social economic implications, we haven't covered this in our paper. Sure, we will do this in the next incremental research when we will perform. But we have correlated the change that we have depicted through the climate. What are the implications of on the climate of this particular area happened over these past 5 years? So we are much more inclined towards the land use, land cover classification and its impact on the climate instead of the social economics. But surely this is this point that has been raised by you is we will inculcate in our next section. But as far as concerned about the climate changes that we have depicted, like the level of NO2, SO2, though they have been decreased over the past 5 years, but the PM10 value, we have observed that it has been drastically increased over this critical region because it is an industrial region where we have done our study. So yes, sir, we will social economic impact, we will definitely inculcate for the next incremental research.
No, because I just mentioned it because they're talking about zone, and maybe that would be in the long run change the scenario. In the longer run, maybe some
You're
other
right.
aspects will come.
Yes, you're right, sir. Sure, definitely. Sir. Thank you.
Thank you so much, ma'am. Moving further with the last paper title of the day, a hybrid framework of epileptic seizure detection using wavelets and ML classifiers under the paper ID 619. I would like to call Dr. Manu YM for the presentation. Are you there? I believe that ma'am is not here, so moving further, um, to end this to end this session, I would like to first of all thank everyone present over here, and especially the session chairs of the day.
Thank you.
Sorry, is there the last paper or not? Thank you so
Ma'am,
much.
yes, ma'am. Ma'am, he's not there.
Okay, thank you.
Yes, ma'am.
Thank
Thank you
you
so
to
much, ma'am,
everyone. Thank you
for
to
joining this
organization.
session. Please say some of the insightful words about the session.
Thank you for this. I'm very honored to receive this. Thanks for involving me in this important international conference. I think it is a great opportunity to share the research. Today, this morning, every paper is very interesting. How I hope to all participants to have a future with to achieve great opportunity to achieve the publication in high-rank journal. Thanks for the organization. Thanks, Aparnan, for manage this session in very excellent way. I'm very honored that thanks again to involve me as a chair in this discussion, this section.
Thank you so much, ma'am. And I would like to also thank the second session chair of this session, Mr. Karni sir. Sir, I would like to, if you would like, you can please say some of the insightful words.
Thank you, Punna. It was a very nice session, and you have, conducted it very well, nicely. And some of the topics were very, interesting in the sense that maybe they have lots of thing in future to do. They can do that. Some of the papers are not presented. I think 3 papers are not presented. So maybe they would be. I do not know whether they would be. In some other session they would present those papers or not. But overall, this was a very good session. And again, thank you, all of you, and Professor Rivelo for this, for also chairing the session, and the organizers, Professor Vijay Singh Thakur, all of you. Thank you very much.
Thank you so much, sir and ma'am, and everyone present over here. We conclude today's paper presentation session at Nice Teas. We sincerely thank all of our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chair again for guiding the discussion with depth and clarity. Now, I would like every one of you to please turn off their camera so that we can have a group photograph for the memory. One minute, just 1 minute. Dishita, please try to take the picture from your side as well.
Bye to everyone. Team, I hope to meet you soon. Have a nice day to all participants. I'm honored Professor can narrate as a co-chair with you. Bye. See you. I hope to meet you in presence. Bye. And thanks,
Thank you,
Professor
everyone.
Rattore, for this conference, and also for this session. Bye-bye. See you soon, I hope, in the future. Bye.
Thank you, ma'am. Bye bye, everyone.